me. Okay. Ready? Shall we start the work? Exam starting from December. We are within this time. More works are there. Maths before maths exam. How many days are there? Good morning, everyone. Maya, good morning. Good morning. Huh? First exam is Maya. Just say me which number should I add? Maya, which number should I add in group? New group? Hi, Mukunda. Now look at the last class, electricity till that part we have done. Today what we will do is an electricity session. I'm not going to share any link to group. Okay. Now we are starting the work, please. Get ready for it. So electricity part we are going to start electricity questions we had to do. So last class till 21 questions we have finished. Now what we will do is remaining questions we are going to go for it. Get ready for it, please. Sneha, good morning. Now look at what we are supposed to do here is we will start the class today. Just get ready for it. Triple Kundram also I need to one time inform. Fine. So now look here. Sanjay, good morning, beta. So now last class we have had discussion about questions. Now what we are going to do is we will be starting the questions and your time starts now. Question number 22, come on, go for it. Question number 22. Question number 22. Good morning, Divya. I need to teach today power also. So please see the question as fast as possible. Start answering. Okay, start answering the questions, please. Yes. Come on, join. Answer question number 22 as fast as possible. What is the answer for question number 22? C. How many people have joined? Everyone, please pay attention here. See, two resistors of resistors 2 ohm and 4 ohm when connected to a battery will have what it will have. Everybody, please check. Same current having flowing through them. See, connected in battery. They did not said about any type of connections. Okay, but what the two resistors of resistors 2 ohm and 4 ohm when connected to a battery will have same current flowing through them when connected in parallel. No, current will distribute. Same current flowing through them when connected in series. It may be true. Okay, we don't know what and all actually they are looking forward for. Jasmita, Kavya, after that, Ashmita has given the answer. Same potential difference across them when connected in series, different potential difference across them when connected in parallel. So here two things are there. Different potential difference when connected in parallel is not correct. Same potential difference across them when connected in series, it is not there. Same current flowing through them when connected in series. So B is the correct answer. B is the correct answer. How many of you have given B as correct answer? Actually, B is the correct answer. Very good. And first person who has given the answer is Jasmita Kavya. Okay, good. So now we will go for the next one. Today, heating effect of current also we will discuss. And your time starts now. Come on, go for it, children. Start answering the question. The resistances of 2 ohm, 3 ohm, 5 ohm are connected in parallel to a 10-volt battery of negligible internal resistance. The potential difference across the 3 ohm resistance will be. Come on, start solving. See, you need to understand here first thing. I'm just going to explain this section so that you can be able. So the three resistances of this are connected in parallel. So parallel connection generate. One is there, second is there, and third is there. So three are connected in parallel. 2 ohm, 3 ohm, and 5 ohm are connected in parallel. After that, they are linked to a 10-volt battery of negligible resistance, internal resistance, the potential difference across 3 ohm. We know one thing, potential difference remains same or different in parallel connection. Same. Potential difference remains same and current varies only. So based on that only, we are going to solve. So potential difference remains same means V will remain same, so it will become 10 volt only. So this is not a rocket science, very simple question. 23rd question, we need not to solve also because we should only directly write the answers. Children, one more thing, please kindly check if people are live or not. Some answers are lagging. Okay, for me answer is coming late, so you check you are live or not. So here we will go for next question and your time starts now. Question number 24, please. Very good, Ashmita. Question number 24. Kavya, your sister Gopika, she is not attending classes regularly. And your time starts now. Come on, go for it. I waited lot. This much we cannot wait. So what is the question? Two resistances R1 and R2 are connected with the cell in a parallel form. Okay. So two resistors R1 and R2 they are connected in parallel. So let's check this one out. If they are connected in parallel, two resistors R1 and R2 are connected in parallel with a cell in a parallel. Find the ratio of current flowing through R1 to the current flowing through R2. So you need to find the ratio of current flowing through R2 and R1. So definitely we need to check one thing. Two resistances are connected with a cell in parallel. Find the current flowing. So what will be the resistance for first one? First case will be B is equal to I1 R1, correct. Second one, B will be equal to I2 R2, correct. Now B is same, so I1 R1 is equal to I2 and R2. So they're telling find the ratio of current flowing through resistance 1 to the current flowing through resistance 2. So find the ratio of current flowing through resistance R1 to R2. So here what can be the conclusion? Yes, R2 is to R1. So here I think the question might be find the ratio of the what you call current flowing through R1 to R2. So R1 current flowing through I1 to R2 is R2 by R1. Understood. So ratio will be coming R2 by R1. So those who have given the answer, very good. I think Mukundan, Kavya, Ilavarshan, Sanjay, Tarun, very good. So it will come as R2 by R1 because they are telling current flowing ratio. So current flowing ratio means I1 by I2 ratio, and it is coming as R2 by R1. I1 by R2 ratio, and that is coming as R2 by R1, and that's the correct part. Are we going for the next question? Ishrat is still absent. Sai Teja, Tarun. Yes, the correct answer is that. So those people whose name I am calling out, within 5 minutes you have to respond. Tarun, Saiteja, Praveen, these three people. Good morning. Sneha is there. Now come on, start solving this question, please. Ma, Kritika, Sophia. Which one, beta? Answer is 25th question. What is the answer? Tarun, yes, Tarun is there. Sophia is there. Very good. Maha is there. C is the answer. A is the answer. People are telling different type of answer. What is the answer? C. I'm not saying C A. Whatever you are writing, you write. After the time, will analyze and inform you. Yes, the correct answer will be. We are going to check this one out. Two unequal resistors are connected in parallel. Which of the following statement is true? Okay, Ilavarsan is there. Where is when the current is same, what is the following statement is true? So if parallel connection means current is not same. So this one is wrong. Current should be different. Jotam, this part is wrong. After that, current is higher in higher resistance. Current is higher in higher resistances. Is it like that? Nothing. So voltage drop is same across both, and voltage drop is lower in lower resistances. These two things are not, but voltage drop is same. Why? Because potential difference remains the same. This is the most important thing. Potential difference remains the same. So since the potential difference remains the same, the voltage drop is same across both. So this is the most important thing. The voltage drop remains same across both. So definitely voltage drop is same across both. It will come in that situation only. So now this is one thing. So answer is C. What is the correct answer? C is the correct answer. Understood? So now we'll go for the next part. This is CBSE 2020 question. Rest is your wish. Come on, go for it. Jasmita has given the answer D. Let's go for it. Check. Don't you think, Jasmita, you have... okay, Sanjay has given answer A. Okay. Narayana has given answer A. Kavya, Ilavarsan, Tarun, Sharmila. Now everybody started giving answer A. Maha A. Okay, let's see. Let's see. Jotam, what is your answer? Jotam, you are very slow in answering the questions. Now look here. So maximum, how many resistance we can add? Maya has given answer A. So maximum resistance which can be made using 4 resistors, each of resistance half ohm. So 4 resistors, each of resistance half ohm. So definitely, what is the maximum resistance? So maximum resistance means we need to add it in series. We need to add it in series or parallel. We need to add it in series. Then only we can get maximum resistance. If we will add in what you call the parallel, we will get minimum resistance. So series connection will get maximum resistance. So equivalent resistance is equal to 1 by R plus 1 by R plus 1 by R if it is connected in parallel. So parallel will give another content, understood now. So series connection is maximum giving, so 1 by 2, 1 by 2, 1 by 2 plus 1 by 2. So it is giving how much to you? It is coming as 4 by 2, and 4 by 2 is coming as 2 ohm. Understood? So correct answer is coming as 2 ohm. And some people, you know what mistake they are doing? They are thinking that resistance is half. So very nicely what they are doing is they are connected in parallel, because they think that in parallel it will be there, but it is 1 by R. Understood? So here in parallel it is 1 by R, sorry, 1 by R is there, and then 1 by 2, and then 1 by 1 by 2, and then 1 by 1 by 2, and then 1 by 1 by 2. Understood? So everything will come 2, 4, 6, 8. So 1 by R is equal to 8. So R will be equal to 1 by 8. It will become very, very less. So only answer will be 2 ohm. Understood? So maximum resistance means it must be connected in series. Okay? We will go for the next part. So now look here. Equivalence resistance of 4 ohm resistances is in parallel is 4, 1, equivalence resistance of 4 ohm connected in 4, of 4 ohm resistances. Come on, find out 4 ohm resistances. Super. Who has given the answer? Ashwita has given the answer. That's very cool, Ashwita. That's very fast also. Equivalent resistance of 4 ohm resistances connected in parallel. So how, thank you for liking the class, boss. But definitely some people are answering very fast. So here it is coming as parallel connection now. So 1 by R is equal to 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 4. So 1 by R is equal to 4 by 4 is equal to 1. So resistance is coming as 1. So those who have given answer B, they are absolutely correct. So the correct answer is B only. Kritika, very late. This is not good. So this is the correct answer. Kritika, answer is exactly what B. So last phase, people must be knowing what time they should be awake and what time they should sleep. So question number 28, and your time starts now. Good morning, Prince. To be late, I have put I have. Yes. Now look at when we are talking about this, everybody please check your live or not first. So three resistors of 1 ohm, 2 ohm, and 3 ohm are connected in parallel. In combined resistance of three resistors should be, means combined means together. Combined means together. Combined means together. Solve. What is the answer coming? Combined resistors means combined means when you add them together and then you are getting the answer. Less than 1 ohm, equal to 2 ohm, but between 1 ohm and 3 ohm, like that question coming means very specifically try to answer the question. See, so here parallel means it is coming as 1 ohm here, and then this part will be coming as 2 ohm here, and this part will be coming as 3 ohm here. So definitely it will be 1 plus 1 by 2 plus 1 by 3. Understood? Equivalent resistance combined, if we are saying that this, which is coming 1 by R, so 3 to the 6 will be coming 6 plus 3 plus 2 equal to 1 by R. So 11 by 6. So R will be equal to 6 by 11. So it will be less than 1. 6 by 11 is less than 1 ohm. Why we are going to go here and there? 6 by 11 is less than 1 ohm, and that is the correct answer. 6 by 11 is less than 1 ohm. 6 by 11 is less than 1 ohm. Very good, super. So here we will be going a little bit fast. Now we will go for the next question, question number 29. Because two more questions after that, heating effect of current I am going to teach. This is one part question. Now we will be studying the second section.
I can't even hardly normally.
After I will talk to you. Some tonic has to be given to some students. Come on. What is the minimum resistance which can be made using 5 resistors, each of 1 by 5? Minimum resistance. Then to parallel. 5 resistors. 5 resistors, each of 1 by 5. 25. So 1 by 25. B is the correct answer. Without solving itself, we can say B is the correct answer. How? Look here. For those who have not understood, I am solving for them. See, minimum means connected in series or parallel. Minimum means connected in parallel. So 1 by R is equal to 1 by 1 by 5 plus 1 by 1 by 5 plus 1 by 1 by 5 plus 1 by 1 by 5. So 1, 2, 3, 4, 1 by 1 by 5. So 1 by R is equal to 5 by 1 by 5. So 1 by R is equal to 25. So R will be equal to 1 by 25. So this will become the minimum resistance. Understood? So this is parallel connection. Absolutely correct. So this is question number 29. We have finished this one. This PDF will be available today in that main group. So now look here. A wire of resistance R is cut into 10 equal parts, which are then joined in parallel. The new resistance is super. So a wire of resistance R is cut into 10 equal parts, which are then joined in parallel. The new resistance will be, definitely it will be less or more. The new resistance. Come on, say. What is the new resistance? The new resistance will be 10 times added, na? So 10 by R. So definitely it will become 0.1. It will become 0.1. Same strategy we are going to put. So it is cut into 10 pieces. Cut into 10 pieces and connected in parallel. So when cut into 10 pieces connected in parallel means 1 by R, 1 by R till 1 by R 10 times. So it will become 1 by 10 by R. So definitely the new resistance will become what? The new resistance will become 0.1 R. The new resistance will become, so because all the resistors are getting added 10 times, na, so the new resistance will become 1 by equivalent resistance. So that is 10 R. So it will be what? Resistance will be 1 by R by 10, so 0.1 R. 0.1 R is the correct answer. I hope everybody understood. So now we will be going, can you put one minute, sir? So this is the end of this part. Now we are going to, curtains, can you put, light is coming. Just 1 minute, wait. Screen. So everyone, yes, Ishrat, you saved yourself in good time only. Now look at it. We will be going to the next part, heating effect of current. Everyone please pay attention here. So if somebody will be discussing about power, last class itself, we have studied that power is equal to work done by time. Okay, power is equal to work done by time. Now, efficiency of a machine and the working capability of a machine. If somebody will be discussing you rate, we are telling rate. So we rate electrical appliances in kilowatt and hour. Understood not? So kilowatt hour is the way we are exactly going to rate the efficiency of a machine. We are going to solve numericals related to it. Okay. Now the first word is electrical power is equal to power by, so one by one, we are exactly going to discuss this. So be very attentive, listen and solve the numericals. I'm giving you numericals. Okay, get ready for it. Okay, because you know in the first part of the class we have studied that this one I'm removing. In the first last part of the class, what we have studied, potential difference is equal to work done by amount of charge. Understood? This was our first formula we have studied. Potential difference is equal to work done by amount of charge. After that, we studied current is equal to total amount of charge flowing in the circuit by time. This we have studied in the second phase. Correct? No? Now we are studying power is equal to, then we have studied Ohm's law. V is equal to IR and it was applicable at constant temperature. Understood? Then we have studied R is equal to rho L by A. This was the four basic formulas we have studied in this chapter. Okay, and then parallel and series connection we have studied. So that parallel and series connection formula is different. So now here these are the four important formulas. Till now we have introduced and we have learned. Got it? Now we are going to introduce what? Power is equal to work done by time. So definitely how much power will be there, that much work will be done. Correct now? So if I am having lower power, like you people are talking in a very simple way, in a zero level method, physics I am teaching, like when somebody will be asking you, hey, how much power you are having? Then you will say, hey, I am having power here, I am having more power. I can lift what you call 5 kg. One will say, hey, I am having more power, I can lift 10 kg. Then your friend will come and your friend will lift 100 kg. Understood? Not? So definitely who is having maximum power? Understood not? Why? Because the work done is very high. In respect to time, the work done is very, very high. So these are certain things we people are knowing. Means power, whenever somebody will be discussing, is equal to work done by time. Power is what beta? Work done by time. Now we can write power different formulas. Okay. Now work done can be analyzed with potential difference also. Correct now? So now from this formula, what I can generate a new formula of power. Now look at whatever is given to us, with this we will start generating. Understood or not? So because you remember one thing, how much power means how much content, P is equal to VI, that all formula we will generate, but more than that we can understand first. See how much you have internal energy, that much work done you will do. Understand or not? So energy is one of the most vital thing here. The energy which is exactly the current is converting into heat is also one of the most important thing. Why? Because the continuous supply of current, the drift velocity will be generated, the continuous supply of current will be there. At that particular moment, what will happen? Since the continuous supply of current will be there, at that particular moment, one small work will be happened, and that small work will be the circuit will get heated up. That's a very usual method. Correct now? So if you will allow the current to flow very easily, then too it will heat, and if you will not allow the current to flow, then it will heat more. Understood? Because the resistance is high. So higher resistance create problem. How higher resistance is creating problem? Because the energy of the current will start getting converted into heat, and this mechanism we are using in electrical appliances. Understood? So those electrical appliances which are like heater, toaster, geyser, we are not using normal wire, copper wire. For heating impact, we are using nichrome. Understood? Which is not a wire, which is an alloy. What is nichrome? Nichrome is an alloy. So children, are you all ready? So now we will start this work. Now let's go for it. Yes. Now power is equal to how many times formula we can. So if I want to remove work done, in specifically when we are talking about current, then it will become V into Q. So power is equal to V into Q by T. This will become our fifth. This is our fifth formula. This will become our sixth formula. Correct? So we can write like that. We can write like that. Power is equal to, yes, we can write in this format power formula. Now Q is equal to IT. V is equal to, now what is Q from equation 1? We use which equation? From equation 1 we substituted. Now P is equal to, V is there. Instead of Q I can put IT by T. This will become our equation 7. From equation 2 we put, so T and T got cancelled, P is equal to VI. Done? P is equal to VI done. So now VI, P is equal to V into I. Now V is equal to, V is equal to IR. So it will become IR into I. So P will be equal to I square R. This what we have used. This can be written as, this can be written as 7th, 8th formula from which equation? From Ohm's law. Ohm's law is equation 3. Understood? Now same equation R can be written as V by I. This and this will get cancelled. So same content is coming. But if I really wish to remove, because VI already we have, VI already we have, I square R already we have, this part we have, this formula we have. So now if we can remove I, then what will get come? Then V by R will come. If I want to remove, so here I square by R square into R, this will become our ninth formula from equation 3 itself, Ohm's law. This time this R and this part will get cancelled. So now what formula will come? Can you tell me? It will become P is equal to V square by R. So without touching book, we can generate our formulas. Without touching book, I have generated, how many formulas we have generated? Nearly 9 formulas we have generated. Understood, Navita? Huh? So this is exactly the power content. So we need to understand that every electrical appliances will have its own power, and the power will always be exactly measured in kilowatt hour. Understood or not? Kilowatt. 9 formulas is not only there, more will be there. We will be doing that work also. So definitely with this we can be generating how many formulas. Heating effect of current formula is also there. We will be discussing about that. So 1 volt, I hope all the formulas P is equal to VI, P is equal to I square R, and P is equal to V square by R. Understood? P is equal to W by T. So all these formulas we have understood. Now if somebody will discuss this, now I am doing one small kuti work. Power is what? Power is what? You people are exactly this much intelligent. I'm going to discuss some things with you people. Get ready, kilowatt hour. But one magic work I'm going to do. Thank you for liking. But the most important part is still. So 1 horsepower is equal to Who can answer this question? 1 horsepower is equal to how much watt, beta? Yeah, worked in particular time period will be there, beta. But 1 horsepower is equal to 1 horsepower is equal to how much watt? Anyone? 1 horsepower is equal to how much watt, beta? 1 horsepower is equal to how much watt? Kilowatt, no. 1 horsepower is equal to 746 watt. Note down. 1 horsepower is equal to 746 watt. Now, when the circuit is connected in series and parallel, how can we find the power of it? Yes, 746 watt. How can we find the power of it? So now, till now, nobody talked like that. So we are the first one who will be discussing about power of series connection. How can we find the power of series connection? Till now, we did not discuss about power of series connection, boss. So something has to be done, correct now? In series connection, beta, we know that power is having some relation. Na? So every resistance will have some power, correct? Na? Because the resistance decide the amount of current flowing through it, correct? Na? Because the resistance is restricting the flow of current. So in series connection, potential difference varies. Potential difference varies. Correct na? In series connection, what is varying, beta? Potential difference varies. So now we need to be very acquainted here. Now, if somebody will be discussing this part with us, how we are going to discuss? But potential difference in series connection is varying or remains the same? Say vary. I am writing one formula, children. Just check this one out. In series, potential power is equal to 1 by P1 plus 1 by P2 plus 1 by P3. Can I write like this? I did a very massive work. This is called as equivalent power. PEQ, note down, it is called as equivalent power. What is PEQ is equivalent power, but how it came? The question is not this. The question is not this. I'm not an idiot. I will ask this question. I'm not the idiot. I will just tell you this formula and then I will say go and sleep in home. This is not at all this case. We are going to discuss about it. So this is resistance R1. So when resistance will be R1, same current will be flowing. What will be flowing? Same current will be flowing. Okay. Now current remains the same. And here this will be R2, but here it will be V1, it will be V2, it will be V3, and this is R3. So definitely its power will be P1, its power will be P2, and its power will be P3. Done? So resistance different, power content written. Now we will be understanding the most important thing. So total power. Total power. So beta, but we know that only one thing. Why we are going to think about that much thing? Power is equal to V into I is there. Power is equal to V into I is there. Correct now? So that means something has to be done with potential difference. Correct na? Because here potential difference is varying. So total potential difference is equal to V1 plus V2 plus V3. So potential difference V can be written as, I will use this one, P is equal to VI. So V is equal to, check this one out. So P is equal to VI. So can I write V is equal to P by I? I can write like this now. P is equal to V by I. Very carefully, because after that I will ask question. कर सकते हैं? क्या कर रहे हैं अभी हम कॉमेडी थोड़ी ना कर रहे हैं. चेक करो. वह बहुत सावधानी से चेक करना. P is equal to VI is there. Correct? So V will be equal to P by I. I will be equal to I is equal to correct now. Now शांति से देखो बच्चों, see very clearly. Here in series connection, why it is coming as 1 by P1 plus 1 by P2 plus 1 by P3. So V is equal to P by I, can I write total? P by I, but P is changing. Resist in current remains the same. So if current is remaining the same, that means we can write 1 by V, 1 by V, 1 by V. So here V is equal to current in both the situation remains the same. Left side also current remains the same, right side also current remains the same. So when left side current is remaining the same, it will become what? V by P. Understood? Now here it will become V by P1, V2 by P2, V3 by P3. Like this we can say na, but overall when you add all the potential difference, power will be exactly coming like that. So definitely V by P will come. So when we will be analyzing this part, potential difference V1 plus V2 plus V3 is coming as what beta? 1 by P1 plus 1 by P2 plus 1 by P3, because all the potential remains the same. So since the see, all addition of potential difference will become V only. Understood? V1 plus V2 plus V3 will become V. Current remains the same. Current left side and current equal to right side remains the same. So because of that only we will analyze it and we will write it out. Correct? Because if I have to write like this, Vp is equal to Vi, then we can write as V is equal to P by I. Correct? V is equal to P by I. We can write here V is equal to P by I. P by I. Now here it will become what? P1 by I plus P2 by I plus P3 by I. Correct? So P1 plus P2 plus P3 by I will come if we will take V. Got it? So here we are going to write like this only. R is equal to V by P. It will get added. Very good. So beta here this part is coming means it is a problem for us because V is not giving us a correct answer. So here big problem will come. Understood? Now we will be seeing another part. This section is going to solve our problem. So resistance in parallel will answer our question. Got it? Because parallel means it will go series because R is inversely proportional to P. You remember this one. R is inversely proportional to P. If I write here, total potential is equal to this part is coming. But still it is missing. Now we are going to compile all the thing together. We have studied this part, yet we are not satisfied. We are studying this part, yet we are not satisfied. Because V1 plus V2 plus V3 will give you total potential difference. Now, where should I go and how should I write? Now, I am only going to do one small table. I know that P is equal to V square by R. Understood? So, when I am writing P is equal to V square by R, P is equal to V square by R. Correct? No? P is equal to V square by R. Correct? What I wrote here?
P is equal to V to V square.
V square by R or into R?
Into R.
Where are you, sir?
Last one.
Punch you. So only I am asking because you are playing there. V is equal to V square by R. Understood? So when resistance in series will be there, when resistance in parallel will be there, how you are writing? 1 by R is equal to, so P and R, are they directly related or series? They are directly proportional or inversely proportional? Inversely proportional. So now R equivalent is equal to R1 plus R2 plus R3. This is for series connection or parallel connection? This is for series connection. Series connection. So series means it will become 1 by P eq is equal to 1 by P1 is equal to 1 by P2 is equal to 1 by P3. So if I want a concrete answer and I am unable to go with current part because current and power they are symbolic and they are creating problem. Here also we are not getting V1 plus V2 plus V3 we are going to take. So definitely resistance gave the entire answer. So resistance in series and resistance in parallel will give you parallel equivalence, power equivalence. Understood? How? One last time I am showing you. Resistance in series. R equivalent is equal to what? Jotam, are you there in the group? This one is there, better. So now R is inversely proportional or directly proportional?
Inversely proportional.
So it will become 1 by PEQ is equal to 1 by P1 plus 1 by P2 plus 1 by P3. If you will ask to many people, they are not knowing all these things. So resistance in parallel, when resistance in parallel will be there, then it will become opposite. Power will increase. Reverse work will do. Resistance in parallel, it will inverse and this is power. Power, when resistance in parallel, then power will become this much. When resistance in series, power will become this much. So this is exactly the just opposite work. This is just the opposite work what we are doing. Power we are finding with resistance in series. So we are seriously mental, but we can't do like that. Understood or not? We can find the connectivity and we can find the content. So in this part you are understanding this 1 horsepower is equal to what, beta? 1 horsepower is equal to 746 watt. That's a very important thing and you must remember this one. Now electrical energy we are going to understand. Power entire scenario we have discussed, 9 formula we have done. Then power we understood that okay, if we will do like this, is it going to be creating problem? Yes, it is creating problem. P is equal to P1 plus P2 plus P3 is coming, but connectivity has to be there. And this is not giving the correct answer. Here also V1 plus V2 plus V3 is coming. Then total potential is equal to total power is coming of the circuit. But this is not separating us. So for separation, only if I want to know the power of the circuit means what I will use? I will use resistance. And when I am using resistance, what I will do? Equivalence, the total equivalent power, this total power is equal to, when connected in series, is 1 by P1 plus 1 by P2 plus 1 by P3. And when in series, when in parallel, it will become P1 plus P2 plus P3. So the power will increase. So this is something we had understood. Okay. So now we are going to go for the second phase. Okay. Are you all ready? So we know that kilowatt hour. Always remember when you are writing kilowatt hour, 1 kilowatt hour is equal to how much watt hour, children?
1000.
But
10,000.
10,000. See, first though kilowatt hour I have written.
Hour is 11 both, ma'am.
Oh, first you remember again. I wrote 1 kilowatt hour. Every single line in numericals is very important. See, you must remember when I'm writing 1 kilowatt is 1000 watt. 1 kilowatt is 1000 watt. The story is not this much. Thank you. The story is not this much. Understood? Now tell me what is 1 megawatt? 1 megawatt. 10 to the power 6 watt. First to write down. 1 megawatt is 10 to the power 6 watt. 1 kilowatt is 10 to the power 3 watt. These are the units to measure the electric power. Understood? These are the unit to measure the electric power. But now we are going to understand that efficiency of machine, engine, whatever work we are doing, how we are exactly going to find the things. Are you all ready? So this is exactly something we need to understand. Yes. So these are some things we. Yes, so we are going to understand some of the things, but before that, on Kuti work, I want to teach you all. So, if somebody will tell kilowatt hour, convert joule, Power unit is what? Power is what now? So 1 watt is equal to 1 watt is equal to C. Power is equal to work done by time. So power is 1. This is work done by time. Work done by time. So power unit is 1 watt. SI unit is 1 watt. So that is 1 joule per 1 second. Understood? 1 joule per second. So in terms of joule, if somebody will tell you to convert, so 1 kilowatt hour, how to convert it into joule? So this is unit of power only. Understood now? So 1 kilowatt hour, how we are going to convert? So 1 kilowatt will become 1000 watt. Correct? Hour will be how much better? Hour is 60 into 60 seconds. Understood? Now 1 watt is equal to 1 joule by 1 second into 3600 seconds. Okay? So now how we are going to write it? A second and second will get cancelled. So now everything is coming in joule. 3, 6, 1, 2, 3, 4, 5. That is 3.6 into 10 to the power 6 joule. So 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule, and I rest my case. We did not did any rocket science. We understood so simply enough. Is it easy or tough? This much we have done without wasting any time. 1 kilowatt, first we converted watt, kilowatt into watt. And 1 watt is 1 joule per second. Second and second got cancelled. Hour, 1 hour is equal to 60 minutes. 1 minute is equal to 60 seconds. So 6 into 00. So 3600. Now 3600 into 000. So this part is coming. So definitely. So this part is exactly going to work. Those people who are coming here for disturbing the class, please kindly don't do this. Exams are नहीं. आपको कहीं पे भी और जाके मस्ती करना है कर लो. But यहाँ पे पढ़ाई हो. So 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. Okay, and please don't do this. This is very. I will not say anything. Public platform. So 1 watt is equal to 1 joule per second. 1 watt is equal to 1 joule per second. This is the most important thing. So 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. This is the most important part. Got it? So now we will be exactly, so electrical efficiency. Electrical efficiency means the household supplies are coming in which unit? Kilowatt hour. Kilowatt hour. Now electrical appliances, yes, I'm going to repeat this one. Please, that's welcome to you, but respect to everyone. That's most important. So now look at that. 1 kilowatt hour is equal to kilowatt hour will become watt. Understood now? So that is 1000 watt. Now 1 hour is equal to how much we have? 1 hour is equal to 60 minutes. Now 60 into 1 minute. So 1 minute is equal to 60 seconds. Now power unit is work done by time. So work is joule by second. So this second and this second will get cancelled. So overall the entire answer will come in joule. And standard format is, what is the standard format of writing, madam? The standard format of writing is 1, 2, 3, 4, 5. 5 zeros are there, but standard unit says that if somebody is writing 5, 1, 2, 3, 4, 5, 6 zeros, then you must not write like this. You must write 5.0 into 10 to the power 6. Understood or not? So this is called a standard format of writing. This is what standard format of writing. So we can write like this: 3, 6, this much zeros. but this is not a standard format of writing in physics. Okay, so what is the standard format of writing is 1, 2, 3, 4, 5, 6. So after 6 digit you have to put decimal. This is the standard notation of writing. And when standard notations will be there, 3.6 into 10 to the power 6 joule answer is coming. Got it? So now beta, every electrical appliances is having a different efficiency. Understood? So in next class, what we are going to study? In next class, first I am telling what numericals we are going to study. We are going to find out in house how the electric bill is coming. Understood? So that is called as electrical energy. What it is called as electrical energy. And electrical energy will be power into time. Electrical energy is power into time. So how power into time will come? Anyone please tell me. Electrical energy power into time. Electrical energy EE is equal to power into time. Why beta? Because a simple answer is electrical energy is equal to power into time. How this is working? Every engine, every machine is doing work, correct now? And it is having its own power. That's true now, it is having its own power. So like if I compare a fan with AC, who is having more power, who is dragging more current? AC. So that means its power is more. So definitely its money will be coming more or less? More. So that means the one who is doing more work, because here power is how much work it is doing. Are you understanding? Here power is how much work it is doing. Very good. So here power is how much work it is doing, beta. And that work will only justify or found the content related to electrical energy. So every month your electricity bill is coming now. So here when we are writing power into time, so here we need to find power. We need to find power. So power will come, certain units will come. So next class numericals we will solve. That time we will be discussing. So electrical energy unit will be what? Kilowatt hour. Electrical energy unit will be, yes, it is there. It is there, but it is in Google Stream for students. So it is okay. So it is coming as kilowatt hour. Kilowatt hour. So what is the unit of electrical energy? Kilowatt hour. What is the unit of electrical energy? Kilowatt hour. Understood? So today evening I am going to finish ethnoic and chemistry part. I am going to discuss, and maths also some important questions we will do. Yeah, it will be online because I'm going Triple Kundram. So from there, Google Meet class I'm going to. Don't miss the class because most important content I'm going to teach there today. So all single classes will be very effective, and you people need to be present continuously. Now listen. So electrical energy is equal to power into time. Power unit is what, beta? Kilowatt. Here it will not be watt. Watt is a smaller unit, and time is hour here. So what is electrical energy unit is kilowatt hour, and 1 kilowatt hour is equal to what, beta? 3.6 into 10 to the power 6 joule. So this is the most important way to generate and write the answers. I hope till here everything is clear. You have understood. How was the class? Did you learn today? So, before whatever videos are there, one video series we are making. That video series we are going to distribute. One work we are doing one time. Okay, because eighth you are having from eighth you are having examination now. Before maths, how many days are there? Maths and science, because blessing school also examination is starting. I want to get the time schedule from blessing school also, and KV school also I want to get. And for any parents, you tell ma'am wants to talk, you better call his father. Ah, father is not there. Okay. Bye everyone. Father is not there. Wait, I'll discuss. Wait. Bye everyone.